To find the domain of a rational function, we need to exclude all of the x values that will make the denominator 0. So what we're going to do is we're going to exclude x values that make x cubed plus 6x equal to 0. So since we're going to exclude them, we're going to set these not equal to 0. So we can factor out the x value. X times x squared plus 6 equals 0. And we can set both of these equal to 0 using the zero product principle. From here we get that x cannot equal 0, and that x squared plus 6 cannot equal 0. So when we simplify this, we'll get x squared equals negative 6. X squared can never equal a negative, so this one does not have any values that we need to exclude. So our answer here will be all x values that make the denominator 0. And in the real number system, the only value that will make the number that will make the denominator 0 is x equals 0. Here we would have plus or minus radical 6i, because it's a negative. So that's not a real number. We don't need to worry about that one. So now we need to write this in interval notation for the solution. To do that, we need to look at all of the values of x that x can be. If the only value that we need to exclude is x is equal to 0, then we can have every other value in the real number system except 0. And the way that we'll show that is either with an open circle at 0, or in interval notation we can just use the open parentheses at 0, which show that we can be every value up to but not including 0. So interval notation is from negative infinity to 0, open parentheses, again excluding the endpoints, union 0 to infinity. And it's generally helpful to graph these so that we can see exactly which values are missing. Again, the only value we have to exclude here is 0.